that might occur to the console. Then finally, there's one important thing about this API, which is that it only allows you to make 3 requests per second. So if you reload the page really fast, then you will get an error with the code 403. And this is an error with a request. So it's a little bit like the 404 error that we worked on before. Remember? So the fetch function does not reject the promise in this case. And so you basically have to do that manually. And so that is step 5. And so with that, you completed part 1. So part 1 is basically about reverse geocoding. And then in part 2, it's time to use the data that you get from step number 1 to render a country. And so take the relevant attribute from the geocoding API and plug it into the countries API that we have been using. And just like we have been doing, render the country and also catch any errors. And for this one, you can actually even copy the code, so there's no need to type the same code, at least if you're in a hurry. So if you want to write the same code again, of course, that's still great, because that will help your muscle memory to really internalize these concepts. Now, if for any reason, by the time you're watching this course, this API here is no longer working, then please just Google for another reverse geocoding API. So I'm sure there should be another one that you can use. Okay, but anyway, once you have all of this done, then you should test your function with these 3 test data coordinates. So hopefully you can complete this challenge and have some fun along the way. So I designed this one to one more time be fun for you. So go have some fun now, and I see you back here once you're ready. All right, so here I am back, and here goes my solution. So where am I is the function that we're gonna create, and that you hopefully created yourself. And so if your code works perfectly, then there's actually not even a need to watch this video probably to the end. But anyway, let's now take this URL format and then do a fetch request to this URL. So fetch, here let's use a template string, because now here we need to plug in the latitude. And then here after the comma, we need the longitude. All right, then on this we call the then method, and here we get the response. Let's just call it res for now, and then immediately we return res.json, which, remember, will return a new promise, and it is this one which then will get the data, because the data is going to be the resolved value of this promise. Right, so that's nothing new. And so let's just take a look at the data here. All right. So let's reload here. Oh, and of course, I need to call this function indeed. So let's grab these coordinates, give it a save. And so now it actually already worked. All right. So let's open it and let's see what kind of stuff we have here. So we have the city, we have so basically the confidence that this data is correct, which is 90%, which is pretty good. So the country is Germany. And then here we have all kinds of stuff. But what matters is actually the country, at least for part 2, which is going to be to render the country. But for now, the task is to log to the console a string, you are in city and then country. So like in Berlin, Germany. Okay, so let's do that. So you are in, and then data.city, data.country, country like this. And all right, so we are in Berlin, Germany. Let's actually already do this with the other coordinates. So let's see what countries we are in. I actually have no idea. All right. So we get undefined, undefined. And so this is actually the problem that I was mentioning right at the beginning. So, so this one, where the API, sorry. So where the API only allows 3 requests per second. And so now we got this error 4 or 3. And so indeed, it is exactly this one. All right. And so one more time, the fetch function is not correctly handling this error. So it is not rejecting the promise, even though this clearly is an error. And so, as you already know, we need to now manually do that. So here we need to now return. And just to make sure, let's take a look at the response. And this doesn't always happen, okay? And so in this case, it actually worked just fine. So one of these here is Cape Town, South Africa, and the other one is Mumbai in India. All right. So let's try to reload again very fast here. And so now we get that error again. Okay. So where is that response? So the one that's associated to 13.381. So that's this one. And so one more time you get that OK is false. So let's use that to our advantage. So if res.ok is false, then throw new error with the error message problem with geocoding. And again, let's actually include the status code here. All right. So here we are throwing a new error. And so we are rejecting this promise that's going to be returned here. But we are, as of now, not catching it anywhere. And so at this point, we would have an unhandled promise rejection. And actually, let me show that to you. So I need to save this a bit faster in order to create the error. So sometimes it's not that easy to catch it. Let's do it really fast here. All right. So now you get uncaught promise, basically. So the error message is already the one that we want, but it should not be uncaught, right? And so indeed, we need to catch any promise rejection. And so let's do that. And all I'm going to do in this case is simply log it to the console as an error. Simply the error dot message. And then I will again like add an emoji here, just so we know that it's our own message. Okay, something is missing here apparently. So here again, we get problem with geocoding. And so now we successfully handled the error and could now do something more meaningful with it if we had to. Like, again, displaying some kind of error message or logging this error in some error tracking application. Now, okay. So I think with this, we actually already completed part 1. So we did 4 and 5 in the opposite order, but that's okay. And so now it's time to use this data to render a country. And so this is essentially what we already did before. So I'm just going to come here and copy that. So let's see where that is. Well, it's even more up there. Or actually, it's not. So actually, I will just copy this part here of the error handling. Oh, and actually, I can get all of it. Okay. So let's paste that here then. Let's get rid of these comments. And of course, now here, we need to do a new fetch. So return fetch, and then Well, actually, I need to go back and get the country as well. So yeah, that's essentially this URL here. Okay. So let's save it. I'm not sure if it's going to work yet. And it doesn't. And that's, of course, because this country here doesn't exist. So the country that we need is stored in data.country. And so here we are now logging this string just like we were doing before. And then based on that country, we have our next fetch here, which we will then return. And then here we have that part where we handle the error if the country cannot be found. And finally, here then we render that country. But it is not going to be a neighbor. So let's get rid of this part. And up there, we called response simply res. So let's do the same here. And for now, let's test it only with one testing data. So let's see. And now we still get an error, cannot read property 0 of undefined. So where does that come from? And so this stack trace here is once again not really helpful. But I think that I still know the answer. And that is because here we actually needed to take the first element of the array. If I remember correctly. Well, now nothing happened. Oh, but I think I know why. And the reason for that is that previously we had this finally here. So we had this finally which set the country's container opacity back to 1. And as we did that, we removed this from here. So right here. So basically now we should set this back here so that we can be back to using it in the future. And so if I save this now, oh, beautiful. There you have it. And this is really amazing. So just using the GPS coordinates, we can now determine the country that we are in and then also display it along with a bunch of information about the country here on our page. And all thanks to the power of APIs and also asynchronous JavaScript. So let's now also test with these two. All right. But now here in one of them, we actually got an error with geocoding. And again, the reason for that is that we can only do 3 requests a second. And so sometimes this then doesn't really work. Oh, but now we actually got all 3. Now, this one here for India looks a bit weird. Right? So this one is India, but when we get the data for India, then apparently, because this country also has Indian in its name, this is then going to be the first country that is found. Right? So there's probably multiple countries for India. But yeah, that doesn't really matter here in this case. If you want, you can just use some other coordinates here. All right. But anyway, again, I hope you had some fun. And this was a great use case for how we can actually use multiple APIs in sequence to create a really amazing result like this one. So we learned what AJAX and APIs are. We used a bunch of asynchronous code already, and we learned all about promises. But what's missing is to finally understand how all of it really works behind the scenes of JavaScript. And so let's find out. And to start, let's quickly review the JavaScript runtime that we talked about way back in the course, just to make sure that the rest of this lecture will make sense to you. So a JavaScript runtime is basically a container which includes all the different pieces that are necessary to execute JavaScript code. Now, the heart of every JavaScript runtime is the engine. So this is where code is actually executed and where objects are stored in memory. So these two things happen in the call stack and in the heap. Now, what's important to note here is that JavaScript has only one thread of execution, and so it can only do one thing at a time. There is absolutely no multitasking happening in JavaScript itself. Now, other languages like Java can execute multiple pieces of code at the same time, but not JavaScript. But anyway, next we have the Web APIs environment. These are some APIs provided to the engine, but which are actually not part of the JavaScript language itself. So that's things like the DOM, timers, the fetch API, the geolocation API, and so on and so forth. Next up, there is the callback queue. And this is a data structure that holds all the ready-to-be-executed callback functions that are attached to some event that has occurred. Finally, whenever the call stack is empty, the event loop takes callbacks from the callback queue and puts them in the call stack so that they can be executed. So the event loop is the essential piece that makes asynchronous behavior possible in JavaScript. It's the reason why we can have a non-blocking concurrency model in JavaScript. And a concurrency model is simply how a language handles multiple things happening at the same time. But now, how does this non-blocking concurrency actually work? And why is the event loop so important? Well, let's find out. And let's focus on the essential parts of the runtime here. So that's the call stack, the event loop, the web APIs, and the callback queue. So as you know by now, a JavaScript engine is built around the idea of a single thread. But if there's only one thread of execution in the engine, then how can asynchronous code be executed in a non-blocking way? Well, that's actually the big question that we're going to answer in this video. So essentially, you will learn how the JavaScript concurrency model really works behind the scenes using all the parts of the JavaScript runtime that you already know. And as always, we will do this by looking at a real code example. So let's walk through the code line by line, and I will keep updating the call stack as we go. However, you already know how the call stack works, and so it's best that you focus more on the code and on the web APIs and callback queue. Okay, but now let's start by selecting this image element, and then in the next line, we set the source attribute of that image to doc.jpg. And as we learned before, this will now start to load this image asynchronously in the background. But this time we can actually understand what that mysterious background actually is. So, as you already know, everything related to the DOM is not really part of JavaScript, but of the web APIs. And so it's in the web APIs environment where the asynchronous tasks related to the DOM will run. And in fact, the same is true for timers, AJAX calls, and really all other asynchronous tasks. So again, these asynchronous tasks will all run in the web APIs environment of the browser. Now, if the image would be loading in a synchronous way, it would be doing so right in the call stack, blocking the execution of the rest of the code. But as we already learned, that would be terrible. And that's why loading images in JavaScript is asynchronous. So it does not happen in the call stack, so not in the main thread of execution, but really in the web APIs environment, as I mentioned before. Now, if we want to do something after the image has finished loading, then we need to listen to the load event. And so that's exactly what we do in the next line of code. So here we attach an event listener to the load event of that image and pass in a callback function as always. In practice, this means to register this callback in the web APIs environment exactly where the image is loading. And the callback will stay there until the load event is emitted. So we're handling asynchronous behavior here with a callback, just as we learned before. But anyway, let's go back to the code. And so in the next line, we make an AJAX call using the fetch API. And as always, the asynchronous fetch operation will happen in the web API's environment. And again, that's because otherwise we would be blocking the call stack and create a huge lag in our application. Finally, we use the then method on the promise returned by the fetch function. And this will also register a callback in the web API's environment so that we can react to the future resolved value of the promise. So this callback is associated with the promise that is fetching the data from the API. And that's going to be important later on. So with this, we have now executed all the top-level code, so all the code that is not inside any callback function, in a synchronous way. We also have the image loading in the background and some data being fetched from an API. And so now it's time for this to get really interesting. Let's say the image has finished loading, and therefore the load event is emitted on that image. What happens next is that the callback for this event is put in the callback queue. And the callback queue is basically an ordered list of all the callback functions that are in line to be executed. And you can think of this callback queue like as a to-do list that you would write for yourself with all the tasks that you have to complete. So the callback queue is also a to-do list of a kind, but with tasks that the call stack will eventually have to complete. Now, in this example, there are no other callbacks in the queue yet, but there could be, of course. So if there were already other callbacks waiting in line, then this new callback would, of course, go straight to the end of the queue, and there it would sit patiently for its turn to finally run. And this actually has big implications. So imagine that you set a timer for 5 seconds. And so after 5 seconds, that timer's callback will be put on the callback queue, right? And let's say there were already other callbacks waiting, and let's also say that it took 1 second to run all of those callbacks. Then, in that case, your timer's callback would only run after 6 seconds and not after 5. So these 6 seconds are the 5 seconds that passed for the timer, plus the 1 second that it took to run all the other callbacks that were already waiting in line in front of your timer. So what this means is that the timer's duration that you define is not a guarantee. The only guarantee is that the timer's callback will not run before 5 seconds, but it might very well run after 5 seconds have passed. So it all depends on the state of the callback queue and also another queue that we're going to learn about in a second. Now, another thing that's important to mention here is that the callback queue also contains callbacks coming from DOM events like clicks or key presses or whatever. Now, we learned before that DOM events are not really asynchronous behavior, but they still use the callback queue to run their attached callbacks. So if a click happens on a button with an event listener, then what will happen is just like what I illustrated here with the asynchronous load event. But anyway, now it's time to finally learn about the event loop. So here is what the event loop does. It looks into the call stack and determines whether it's empty or not, except of course for the global context. Then if the stack is indeed empty, which means that there is currently no code being executed, then it will take the first callback from the callback queue and put it on the call stack to be executed. And this is called an event loop tick. So each time the event loop takes a callback from the callback queue, we say that there was an event loop tick. So as we can see here, the event loop has the extremely important task of doing coordination between the call stack and the callbacks in the callback queue. So the event loop is basically who decides exactly when each callback is executed, We can also say that the event loop does the orchestration of this entire JavaScript runtime. Another thing that becomes clear from this whole explanation is that the JavaScript language itself has actually no sense of time. That's because everything that is asynchronous does not happen in the engine. It's the runtime who manages all the asynchronous behavior, and it's the event loop who decides which code will be executed next. But the engine itself simply executes whatever code it is given. Okay, so this is of course a lot to take in, so let's try to recap what happened here. So the image started loading asynchronously in the web API's environment and not in the call stack, right? We then used addEventListener to attach a callback function to the image load event. And this callback is basically our asynchronous code. It's code that we deferred into the future because we only want to execute it once the image has loaded. And in the meantime, the rest of the code kept running. Now, addEventListener did not put the callback directly in the callback queue. It simply registered the callback, which then kept waiting in the web API's environment until the load event was fired off. Only then the environment put the callback in the queue. Then, while in the queue, the callback kept waiting for